Hey everybody, we're looking at triangle proofs. We're trying to show the two triangles are congruent by some proof or by some reason. We've been using the side postulate and the side angle side postulate. Now, these are not proofs, but this is information that we might need to use to, in a proof. We might have to do this. So the first question is, what other information do you need to prove that these two triangles are congruent by the side angle side postulate? Right now, we're given that EF and DG are congruent. So we already have a side. I'll write it as an S. I have to find an A and an S, another S. So if you look, I'm not really sure what we're going to do. But here's what I do notice. The two triangles are attached right here. If you separated those triangles, side DF would be on both different triangles. So DF is going to be congruent to itself. So that's going to give me another side. So that means that, well, I don't really need to write this, but DF will be congruent to DF. It's not really given to us, but we know because of the reflexive property that that's already congruent. But we would have to show that. So that's the first thing. That gives us the second side. But what about an angle? We need to show that the included angle right in the middle is going to be congruent. So even though I can't prove that it's congruent, the included angle is this angle. See, we have the side, then the angle, then the side. And on this triangle, it would be this angle. So we would have to show that angle EFD would be congruent to angle let's see here, GDF. And if we could, don't forget the symbol in there for angle. So if we could show that, then we could show that the two triangles were congruent, because that would be the A that would go in between, and we could use the SAS theorem to prove that those two triangles were indeed congruent. As it were, I don't have information to do it, but I would need to do that if I could. And then the last bit is pretty easy. Suppose we look at each set of triangles. Which one of these would we use to prove that the triangles are congruent? Well, down here you can see that we have a side and then an angle, then a side, then an angle, then a side. So this one would definitely be a side angle side theorem. Over here we look, I see a side angle side. Over here I see a side angle, no side. I do have a side, but it's not the right side or the right angle. The angle has to be between the two of these. So I don't have enough information for side angle side. I also don't really have any information about the other side, so it's not possible to show this one to be congruent. Matter of fact, they probably aren't congruent. Let's move on. Over here I see side, 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 so that's SSS. And over here, same story, side, 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 side. I can use SSS. However, over here, notice I also have vertical angles, which I know to be congruent. So technically, I could use side angle side as well. So it doesn't matter which one I use for these two sets. We know that they are congruent either with side, 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 or with side angle side. And that's our information there.